point on the perpendicular bisector of a segment is equidistant from the segment's blank.
Okay, segments in point, or I like to say vertices, for a good reason. Yes, I'm recording. And I'm going to relate it to what we talked about on the mnemonic device. We talked about PVC. So I'm going to write out PVC on this one. PVC. Would you agree circumcenter is created by 3 perpendicular bisectors? Thumbs up. Would you agree on that? So then, if y'all remember, a point to vertices being equidistant. Point to vertices being equidistant. That is by circumcenter, which is created by 3 perpendicular bisectors. You'll see it again, okay? The next one, let's see. Brinley, read number 14.
A point on an angle on an angle bisector is equidistant from an angle's point.
Angle sides. And then the other acronym we talked about was not PVC, but PSY. PSI, let's write that out. So we have PSI. In center is created by 3 angle bisectors. Do we agree on that? Yes, give me a nod. So it was a point, P, to the side, S, being equidistant must be the in center, which is created by 3 angle bisectors. That is interchangeable. Everyone good with that? Okay? So our next one is number 17. Number 17 has to do with the mid segments. So on our mid segments, I need to first figure out what this value is. I'm going to call this value n. So what I should do is hide this guy over here. So do I know that 2 is equal to 2? So that's a midpoint. Is 4 equal to 4? Midpoint. So that makes these 2 parallel parts 2-to-1 ratio or 1-to-2 ratio. In this case, and it's bigger, so it'll be 4 times 2, which is how many? 8. And then I'm going to go to, maybe I should use a highlighter on this one. And then I'm going to go to here, which makes it 4, because 8 minus 4. Here to here, which makes it 8, which makes it 16 minus 8. So between these two, they're parallel. And again, it's 1-to-2 ratio. So 8 times 2 is 16. Are we good with that? Okay, it was a 2-step problem. Okay, Nathan, let's read above number 18.
D, E, and F are the points of the sides of the triangle ABC, find the perimeter of the triangle DEF.
Because 18 and 19 are both using the same picture, I'm going to use a pencil for number 18, and then I'm going to use a pen for the number 19. So it's given that, let's first notate everything. We know these 2 are congruent, same as the parallel part. These 2 are congruent, same as the other parallel part in a behavior of 2-to-1 ratio. These 2 are congruent, and it's parallel part. That notation is not going to change. And then for number 18, if AB is 20, I can go ahead and split them and say 10 and 10. Could I mimic that on FE as well? Is it a yes? Okay. And then it says BC is 36, which makes BF how many? 18. And FC is also 18. And what else is 18? DE. And our last one says AC is 24. That makes AE how many? 12. EC 12. And DF 12. Let's see what the question is asking us to find. The perimeter of the inside or the outside? DEF. Inside. So when I add 18, 10, and 12, that's going to give us how many? 40. Done. Now I'm going to erase what I have, but the notation still remains. And for number 19, I'm going to use my pen. So AD is 3. Where else can I put 3? BD and EF. And then it says BF is 6. So where else can I repeat that? F where? C and DE. And then it says EC is 4. That makes AE also 4. And same with DF. So again, we're still looking for the perimeter, the small one. 4, 6, and 3. How many is that together? 13. Done. So our last one on number 21. For number 21, Johnny, go ahead and read.
R is the circumcenter of triangle
Okay, let's notate everything. Because it is a circumcenter, it is a perpendicular bisector, meaning it goes to the midpoint. That means S is a midpoint, these two are congruent. T is a midpoint, these two are congruent. U is a midpoint, so these two are congruent. And on top of that, the unique thing about the point circumcenter to the vertices, they're also congruent too. And if you feel ambitious, go ahead and draw the circle around to collect point O, point P, point Q. If you're done with circles, I get it. So there goes my circle. So those three segments in the inside are representing the radius. Now let's put in what I know and also what I want to find. We're finding OP, RP, RP, OR, TP, and RT. Does this sound like one of our notes question? Kind of, yeah? This is actually exactly the same. So it says OS is 10. Then that makes SP also 10, which makes together how many? 20. And then it says QR is 12. So QR is 12. That also makes RP 12 and OR 12. So RP is 12, OR is 12. Good so far? Okay. And then we have our TP. So it says that our PQ, the whole thing is 22, so they're each 11. So TP is 11. And then for my TR, when I highlight this triangle, it's going to create what kind of triangle specifically? A right triangle. Do we all remember the Pythagorean theorem? So I'm going to call this X. So we have X squared plus 11 squared is 12 squared, which makes X squared plus 121 is 144. How many is 144 minus 121? 30, not 30, but 23? Isn't 23 a prime number? You just leave it inside the fancy radical, 23.